So let's consider how we're going to do a logical architecture. So let's say we want to do two different variants, one for a charcoal grill and one for a natural gas grill. So what we're going to do, we're going to come to the logical architecture here and create two packages. And we're going to go ahead and copy those elements into there, and I'm actually just going to cut and move them in. So all of these will be owned inside one of the I need to lock it. They will all be owned inside one of the two variant packages. So we now have two variant architectures available to us. So I've built out the logical architecture, including the system context for a charcoal grill. Now notice none of the logical elements have any functions or operations, so we're going to copy and paste them from our unitary functional block up here. We'll talk later about how to trace realizations in a little more detail when we go from logical to physical, and you could apply the same technique here, but we're going to tackle it this way at the start. So we're going to assume that loading fuel, cleaning the grill, loading the food, removing the cooked food, those are all jobs that the user is going to have. So I've copied and pasted those onto the user. So notice the user here now has his own copy of those, and we could tweak the parameters, the multiplicities, whether they're streaming. We can now tune the functions to the specific way that this block implements them. So keep that in mind. And so if we want to display them here, we could come and display our operations. So they're now visible. These are the functions that the user is on the hook for in our system. I'm going to go ahead and take the dispense fuel function. Really doesn't happen in a charcoal grill, right? It gets put in there and happens basically right from the start. I guess we can add that to the user as well, since in a way they're dispensing it. But actually, I'm going to put it on the grill body. So the grill body is going to have the effect of dispensing the food. Or sorry, actually we're not even going to bother because there is no fuel to dispense. It's being consumed. So let's see how that works out. We'll take the cook food and smoke food functions and put those on the charcoal itself. And let's see what we're missing. So we're going to go ahead and open up the charcoal grill realization matrix. This basically shows us all of the operations that are in the functional architecture, and we have all of the operations that we have here in this logical expression. And so here we can do a comparison to make sure that we have them all. So the cook food, and we need to add a dependency criteria. We're going to use realization. So this is where we deviate from the magic grid approach a little bit. A realization seems to me to be the correct relationship to use here instead of abstraction. So we're going to say that the cooked food is being realized by the charcoal. We'll set this to row to column so we can just double click and create it. I usually prefer to do that. And the smoked food is being realized. The user is on the hook to clean the grill, load the fuel, load food, load fuel, remove cooked food. So now here's one of the handy features Magic Draw has. We can look for rows and columns that don't have relationships. So we're going to look at the columns without relations. These are the functions that we do not have realized in our logical architecture. So collect dash, that's definitely something that the charcoal grill body is going to do. So we can go ahead and copy the collect ash function and paste that on the grill body. And so the collect dash function, we can double click and notice it's going to vanish. The combust fuel, we can say the grill body is doing also. So we'll copy and paste that down there. And the dispense fuel, in this context, that would be like the natural gas line, putting it into the burner, or a screw feeder. In this case, the grill body is effectively dispensing the fuel also, at least the way we're going to look at this. So we'll go ahead and copy that and give that to the grill body as well. And so there we have it. So there are no unrealized functions in our functional block. So that is a good test you want to have, is that none of your columns are unrealized. Now, we also have parts here in our logical architecture that don't have any functions. They're not realizing anything from the functional architecture. We have to ask ourselves, is that important? Well, the grill context, again, we can just remove that from the matrix. So if we look at what's left here, the charcoal obviously has its job. That's fine. The charcoal grill itself is the system. We don't have to worry about that because it collectively is performing the functions. The grill body has jobs. The grill surface and the legs don't. So I would argue it's not a lot of effort or a lot of utility to put in the legs. They're just supporting the grill. As far as our use cases so far, they're not important. So here's an editorial choice or a modeling style choice. You could choose not to do that, or we could add an activity diagram for support the grill or interface with the ground, whatever. We could consider leg support. There's a lot of ways to handle this. Up to you. I would say the grill surface, though, does have a job of supporting the food during cooking. And that's probably an important enough function that we should add it to the functional block. So that one shouldn't necessarily have any inputs or outputs. So we can just go ahead and add the operation of support food during cooking. And we'll go ahead and paste that on the grill surface. And realize that. So the issue we have now, however, is that none of the activity diagrams have that as part of them. And so we need to go back, and here's a case where, again, as we zigzag around, we learn. So we can go back to the use case diagram here during cooking food. And we need to support the food during cooking. So we'll go ahead and do that. So I would suggest it comes after loading the food, and then it ends up at removing the cooked food. So again, not necessarily trying to make this picture perfect, but I think effectively that is the right place for that to happen. So that happens in parallel. So we have one object flow coming out and one control flow, and that would also apply to the smoke food as well. So again, a little bit of effort here, and we've gone ahead and made these consistent. So there you have it. So that's how you map things to the logical architecture. You realize functions from your functional layer. Again, these could have been in multiple blocks, and you go ahead and realize them to operations that are then being carried out by elements in the logical architecture.